Now we're going to discuss the quotient rule. Functions aren't always multiplied together. Sometimes they're divided by each other in calculus. Now, the quotient rule is a little bit more complicated than the product rule, and that kind of makes a little bit more sense. Basically, it says if I have two functions that are differentiable for all values of x for which g of x does not equal 0, we always have to throw that in. The derivative is the denominator times the derivative of the numerator minus the numerator times the denominator times the derivative of the denominator divided by the denominator squared for all x where g of x does not equal 0. Now the book gives a very detailed sort of derivation, but I would like to do a more generic derivation. Suppose I write h of x is equal to f of x times g to the negative 1. So this is basically 1 over x. It's the same thing. I'm simply rewriting it. What does the product rule tell me? Well, the product rule tells me that the derivative of h of x is equal to, well, what is it? It's the first times the derivative of the second. And what's the derivative of g of x to the negative 1? Well, it's negative 1 g of x to, so it goes down 1, so that's to the negative 2, times the derivative of g. And then it's going to be plus the derivative of the first times g to the negative 1 of x. Now let me rewrite this as negative f, I'm going to drop the x's because that's kind of a pain, g prime divided by g squared plus f prime divided by g. Did I do that right? Now, let me get a least common denominator. So I'm going to multiply both numerator and denominator by g over g, or that one's already there. So let me rewrite this. So this becomes, and I'm going to put the positive one first, g f prime minus f g prime divided by g squared. Now, I used a little trick in there called the chain rule. This to me is just a slightly more elegant way to do it. Now, let's do one. Suppose we have f of x is x over x squared plus 1. Well, let's say my numerator is x. So I like to go in and do these up top. I think it makes your problem a little bit easier. Tell you what, let's change this to h of x. So we're not dealing with the f's and g's. That's not confusing. So let's let f of x equal x. Then f prime of x is just 1. G of x is x squared plus 1. G prime of x is 2x. So the derivative, that's just a prelim work. So the derivative with respect to x of h of x is, let's see, what is it? G of x, f prime at x, minus f at x, g prime at x, divided by g squared of x. Now let's plug in. G of x is x squared plus 1. This is time at f prime, which is 1, minus f of x, which is x, times g prime, which is 2x, divided by g squared. So this is x squared plus 1. Now in the AP test, you don't have to simplify it, but, I mean, you may need to. If it's a multiple choice question, you may have to be able to do some algebra. But let's I at least like to get my numerator straight. So this is x squared plus 1 minus 2x squared. You know what? I forgot my square there. Divided by x squared plus 1 squared. So this becomes 1 minus x squared divided by x squared plus 1 squared. I can't do any more, so I stop. Now, you know what time it is. It's your turn. Turn off the video when you're done and finish your homework. Make sure you put these in your notebook.